Okay. Do we have a stream? Looks like we might have a stream. Okay, we have a stream. Nice. Just a few audio tests, I guess, first. You're gonna hear me twice, just warning you now. Do we have a stream? Still look good. Cool. I guess I can make a start now. Is the description okay? Everything seems good. Description's fine. Does the previous link work? Don't play the previous stream. Okay, this looks like it all works. That's cool. Okay, should be able to make a start then. First thing we need is music, of course. Let's think. We'll start with that. That is loud. Oof, let's turn that down. Obviously I had pre-planned everything. I had all the volume ready, had all the songs I wanted to play ready, and I closed the tab in panic as soon as I started the stream. Great. Let's see how this sounds. This might be a bit too quiet. That might be okay. I'll let it play for a second. Mute myself for just 1 second while I check. Okay, I think that's all fine. So we'll continue that play. Whoops, wrong thing. Start from the beginning. Okay, cool. Now we can actually write some code. So I did notice, I watched my own stream over from yesterday. I think I speak a little bit too fast, so I'm going to try and be a little bit more articulate this time. Let's see how it goes. Okay, so what did we do last time? So let's run a Vulkan build right now. This should be familiar if you were here yesterday. You can't see the demo, can you? That's kind of weird. Why can't you see the demo? 1 second. Does that seem to work? That seems good. Right. Okay. Technical difficulties, of course. Let's see. So this is the Vulkan build where we had like a stub implementation. Yeah, that looks good. So that's where we were before. That all makes sense. Let's try the OpenGL build. Just OpenGL debug. Hopefully nothing goes wrong. Can you see that? You can. Good. So this should have debug-ui, and it's a little bit more. Yeah, there's a little bit more going on here. Everything should be okay here. This is the actual renderer, so I should be able to... No. Okay. Let's try that again. I remember running into this last time, but I don't think I ever fixed it. I think it just stopped reproducing. So when I change the blue component, it's fine. Green component is fine. Red? It's fine again. Is it when 2 of them are open? Ah. So we've already discovered that bug. That's funny. Let's test that a little bit more. So I think the problem is when you have 2 of these open, these color edits have the same name, which means I think they might have the same ID. And then that cert comes up because 2 separate things are open with different IDs. So if I change any of these, this should die. Okay, cool. Let's go again. Do the same thing, but only open 1. This should be fine. This won't do anything, this renderer specifically. Let's close that, open 2. This should change things. It does. I can change these as much as I want. Good. Let's go back to 0. This is fine. Close. This is all fine. I can change these as much as I want. Clearly this seems to work. As soon as I open another one, change anything. Okay. There we go. We've discovered a bug. Ah, that's always fun. That's an imgui thing, and I always make mistakes like that for imgui. Always. Let's have a look. So where is debug-ui for this? Compute kernel, clear color. So the question is, what's the best way to kind of assign, almost, an ID to these so this doesn't happen? I guess the obvious thing to do, I think imgui derives the ID from the string you pass in, so the label here is compute kernel or clear color. We could make it so that it's clear color and then the renderer name, which is going to be unique. That could fix it. That doesn't seem particularly clean though, but just to test, we'll try that. So we'll make a string. I really don't like making strings all the time like this. Like, if you're not super experienced, you will be surprised by how much performance string churn like this just takes up. Constructing strings over and over again, especially on a frame by frame basis or a per object basis per frame in a game, it can be quite expensive. But this is debug-ui, this only runs on debug builds, so I'm happy for it to be really bad and slow. So let's make a string. We'll just call it debug name kernel, and this will just be, what do I call it? Debug name, I guess. That's probably a string. And then we'll do compute kernel. And then what we'll do is we'll take the string, debug name kernel, C string. We have to do the same thing for the clear color. Debug name clear color. This is a bit silly, and this isn't going to look very pretty. I just want to see if it fixes it. So also, these should probably go down here. Like, because you've got debug name here, we're copying strings more than we need to. But we'll focus on that because we have lots of refactoring to do today. Debug name, clear color, C string. This takes in a C string, not the std string. So that seems good. Does it build? Wow. Okay. Day's being kind to me. Let's see what happens. So you can see that, yeah, imgui intermediate renderer clear. This is because the debug name is quite long, so it's kind of hard to see. So ideally, so it still works. We can still change these. Yeah, that's still fine. Let's do, so now 2 are open, and it's not dying anymore. That's good. Let's open all of them. Okay, now I can barely see the window. Let's make this a bit bigger. I wish the text wouldn't take up so much space. Yeah, I can screw with these as much as I like. Sweet. Just to be sure, we'll test another demo. We'll do compute demo. Compute demo has a compute shader in it as well. And you can see here, we have the compute kernel, which is not being used right now. So let's test that. Just tz compute demo. Should work fine. Double check. You can't see this, can you? Let's fix this. Ugh, I need to get better at this. Right, you should be able to see that. Sweet, you can. So, debug-ui. We have our renderers here. None of these don't really care about the colors, but we'll make it a bit smaller so we can see. There we go. I only care about the compute. Window render, I don't care. Compute. So here's the kernel. Compute kernel. Nice. So this works as before. The flashing of the lights gets really bad. Turn my heating off, it's too hot. There we go. Yeah, this is pretty disgusting. So this works as before, and I should be able to open all of these, change all of these as much as I like. Cool. This very clearly seems to work. Change to this guy, no problem. Sweet. Well, that bug's fixed. So let's, I guess we'll probably commit that first. So we just got that change. What should we say? We should be somewhat professional. Fix debug where changing clear colors or compute kernel's dimensions within debug-ui for different renderers at the same time caused imgui asserts. what is the name of the branch we're on? Device renderer debug-ui. It would help if I typed it out correctly. It's kind of embarrassing. That works. Sweet. Oh, there we go. That's a good start to the stream. What can we do next? So yeah, the problem is, if I go back to Vulkan, I've just made all these changes and fixed a really annoying bug, which is great, but the problem is, if I go into Vulkan now, Vulkan build, oh, none of it works here. I only did it for the OpenGL renderer. Do I really want to waste my time doing it all again for the second renderer? But the answer is no, I don't want to do that. So that's what we're going to focus on today. Just to make it clear, if you're not really aware of what I'm talking about, in the engine there's these things called renderers, right? And they do some kind of arbitrary render pass. So let's go into something like this. So if we're on Vulkan, we're using a Vulkan renderer, which is a separate class. If we're on OpenGL, we have a separate implementation. And we've only changed renderer OpenGL, but I want it so that I can change it once and it works for both of them. So let's think about this. So we're going to import front end. This is where the higher level render stuff is. So there's a VK directory for Vulkan, OpenGL directory for OpenGL, and a common directory which has common behavior. And you can see there's already renderer functionality here, but so we should be able to use this basically. So let's have a quick look. An edit builder is not what we care about. The renderer info is kind of, it's like a, if you know the builder pattern, it's a little bit like that, where you define what resources your renderer is going to use, what shader it's going to use, or what kind of work you expect it to do. So for example, is it going to run a compute shader? How many, if it's not, is it going to use a vertex shader and a fragment shader? Okay. If so, how many draws do you want to do? Things like that. And because that always exists for an OpenGL program or a Vulkan program, there's no need to write this twice. So we have this common implementation here. We can do the same for the debug-ui, for the renderer. So what I suggest we do, there's every chance this ultimately gets scrapped, of course, so we'll do a class renderer common. So let me show you the API firstly. I don't want to see that anymore. Topaz source GL API renderer. So this is a concept. If you don't know C++20, I'll try and give you a brief explanation. So if you're aware of interfaces and virtual classes, virtual functions, you will kind of recognize this. This is a little bit like an interface in that you specify what functions you want your classes to implement. But there's no vtable, there's no virtual stuff at all. This is completely free and this is all done at compile time, which is great. So what this does is, for any type T, which is going to be a renderer OGL or a renderer Vulkan, it has to be able to do all of these. So both of them will have this function, t.resourceCount, which returns something that can be converted to an unsigned in. Hopefully that makes sense. And in the last episode we made debug-ui. So both of them must implement this, but I don't want them to implement it separately. So let's work on that with this renderer common. So how do we do this when this is an empty class? Well, what we can do, this is quite complicated actually. I need some way of dealing with all of these. So for example, I want this code to be common, essentially. It's kind of difficult. We could use the curiously recurring template pattern, maybe? That could be interesting. This is tough, actually. How do I want to do this? So anything that inherits from this is guaranteed to have all of these functions. But no mention of debug name. I could add debug name to the API, but I don't really want to do that because that's an implementation detail. I don't want to force any renderer to support debug names, for example. It might be that this isn't doable. Or some of it's not doable. Actually, yeah. So, because there is no guarantee that debug names are even supported, this can't really be done generically, I suppose. That's kind of a problem. So, I guess I might try the age-old technique of nuke the whole thing. All my changes are now gone. Nice. Then we will rethink this. So there's renderers, which are created by devices. Maybe we can do something with the device. Device.cpp. There's a debug-ui for this now, I think. Yeah, there is. So what is this going to do? So this is not specific to any renderer type at all. So this could be made common. That's interesting. Let me look at the header for this real quick. So this should be showing render of Vulkans. Okay, it does. Okay, we could do something quite cool here. So let's go back to our common front end. Except we're not doing render anymore. We're going to do device. Front end, common. Does device exist? Doesn't. We're going to make a new source file. Nice. I very rarely do that nowadays. Okay, so new source file. What I like to do in my header, have a guard. I do like to do this manually. I know people like to use like pragma once, for example. Not really my thing. GL2, enable front end, common. Yeah, you can already see render is there. Device, HPP, copy that. Define, do the rest of our guard. Shouldn't be alien to really anyone here. And this is still going to be TCGL in that namespace. We don't want any special conditional compilation. This should be both OpenGL and Vulkan. So we'll do a class device common. Now let's look at the API. Device. So I don't. So here's an interesting thing. So the Vulkan device specifies a debug-ui function. This should be part of the API, so let's do that. I must have forgotten to do that. Debug-ui. Stood, same as void. So because these are implemented anyway, this shouldn't... Whoa, what's going on here? Okay, let's forget. Let's pretend that didn't happen. Sometimes the Vim terminal gets a bit confused. Show me my demo, please. Load faster. Okay, we have our compute demo. That seems fine. No building problems. I will really quickly check OpenGL as well. I don't want API failures right now. That's going to be really annoying. You can see it's building like a bunch of sources, like 10 of them. So it's definitely changed the API because everyone that uses it is going to have to be rebuilt. Okay, so this is fine. This is good. So we haven't changed anything here now. So what we're going to do, we need some way of being able to iterate through all of the devices. What is the best way of doing that? Okay, here's an idea. Template. So we know that there exists a renderer type called T. So this is a concept again. I'll show you real quick. Renderer type. Here we go. So this is our concept, which defines the renderer. So we have to take in any type here which is considered a renderer. So if that exists, then we should be able to do something interesting with it. Let's think. Yeah, so what we can do here... Right, let's step back for a second. So device Vulkan has these vector of renderers, which we implemented yesterday in the last episode. The OpenGL device does the exact same thing, so maybe that can be made in a common device, which I think would make a lot of sense. Create renderer definitely cannot be, because this could be anything. I guess technically it could, but we won't do that. We'll say device common, so by default, you should have a constructor that does nothing. And then we'll have a vector. So we need to know the exact renderer though. Oh, we do. So a vector of whatever the renderer type is. Let's make it R. A little bit cleaner. Renderers. Let's include the header. Oops. Give me a bit of space. There we go. It's a bit cramped down here. Okay. Must be a type. What? Let's test this. Firstly, I've added a new source, so we need to add it to the build system. GL import frontend wool import. Okay, frontend common renderer shader devices before that, so we'll do tcgl import frontend common device. Get rid of that. Oops. Okay. So let's make this needs to include it, definitely. So we're gonna put it above this guy. tcgl import frontend common device. This is a new file we just made. And now what our device is gonna do, just inherit from it, device common. If I can spell it correctly. Now we pass in the curious template type, which can be renderer Vulkan. Is that going to build? Nothing should be any different. Okay, good. This is Vulkan. Let's test it on the. Let's maybe test the right build. This might fail to build, maybe. I think it should be okay though. This doesn't do anything. This is private, so it won't clash. Let's see. Looks fine to me. OpenGL we won't test yet because we haven't implemented it. So, okay. Let's implement the functions we want to do now. So get renderer and create renderer. All of these can be made done in the common. There we go. Derived from device common. Okay, so these don't exist anymore, which means we have to delete these as well. These guys. Ooh. This is Vulkan specific, so this can't be done. That's annoying. What's the best way of doing this? I think I'm being a bit silly. What do I want to do? What I'm trying to achieve is debug-ui, not these guys. I'm being a bit silly here. Debug-ui. This is what needs to be done. Get renderer, get renderer. Okay, well, what we can do is add a protected function. All it does is do... that's annoying. I have to think about this a little bit. So we definitely need these renderers. So the adding and retrieving should be done here. So is it possible so that device Vulkan can kind of call device common's version of this with this? Yeah, it's absolutely possible. I'm an idiot. Here we go. That was really silly of me. So, actually, this is a tough one. So we definitely need to make something protected. Something needs to be different here. So we'll call it, I suppose. Let's use some periodic templates. Args. What we'll do is we'll just call this render handle, add renderer, and this will take in all the arguments needed to construct a renderer on the spot. Because this is all template, I have to implement it here. You don't know what renderer type is, do you? Let's implement everything we need. If I could type, that would be excellent. So for renderer handle, that's going to be tzgl API renderer. Yep. What's wrong with this? It's unused. That's fine. Okay. Why are you complaining? Oh, it's 'cause it's too late in the night for me. Okay. So, what we're going to assume here is this renderer's pushback just stood forward args. Whatever the arguments are, I don't care what they are, make a renderer with it. That should be okay. Is that stupid? I think we can do better than that. This should be called emplace renderer. Okay, here's what we'll do. We're going to emplace properly, and then we're going to return this renderer's size. Nice one. Then we have to convert all of it to a handle, which is not too bad. Basically, we're doing this, right? So let's think, how would this look? We'd want to do something like device common renderer Vulkan. You don't see it? I'm pretty sure that's just wrong. So place renderer, and all this is going to be. So we're going to have to be a bit more explicit here. Info, and then all this stuff basically. However, it's not going to be able to derive the name because we're doing templates now, so we have to give it the actual thing. I think it's just that. No, I'm an idiot. It was renderer device info Vulkan. That's what it was. Called a non-static member function without an argument. What do you mean? That's weird. Can I do this? Device Vulkan. You're inheriting it here, dude. That's what happens. Is the intelligence lying to me? It is lying to me. I'm being lied to. Unbelievable. I think it's because I derive my syntax highlighting automatically. Let me see if I can fix that. 1 second. I think that's what it is. I think the error is fake, and it's only coming up because I haven't updated it in a while. So where's my compile commands or JSON? If I paste that in, replace it, and then I reload this. Okay, no, it's still complaining. Weird. Well, oh well, that's not my problem. As long as it actually works. Okay, I'm gonna stick with this. I prefer it written like that. It's more obvious. Please don't explode. Cool. Okay, so this is now wrong. So what we need to do is we don't do this anymore. In fact, we don't do any of that. All we do is return this straight away. How about that? Okay, that's pretty cool. So that's being implemented by whoever's inheriting from this. So we'll say derived needs to inherit create renderer still. Not inherit, define. They can use and place renderer as a helper function. Notice I'm using 2 dashes at the beginning of that comment instead of 3. 3 means kind of documentation for the engine. 2 is more of a maintainer's comment, I guess. And yeah, the user, if you're making a game with this engine, you don't need to know about this. Okay, so let's implement get renderer now. So this is going to be just const r, whatever the renderer is, returns that. Get renderer. Renderer handle, definitely always want to use that. Handle, we do the const version first. This is basically going to be this. That should be exactly the same. I'm really curious if this is actually going to work, or I'm about to have like 1,000 errors. Which means this doesn't need, this can't die. This dies though. Both of these go away now. And look, we've saved some space. We're going to be able to do that for the OpenGL one as well, assuming this actually works. This can stay private. Let's see what happens. How many errors am I going to get today? It's building slow. Oh dear. Nice. Why is the problem there? And if I reference to Vulkan get renderer. Really? Device common renderer Vulkans. I did add this. Okay, that's kind of weird. The implementation is here. What's the problem? What if I did... Yeah, renderer. What if I did this? Does that make no difference? That's kind of weird. Didn't expect to get link errors here. That looks encouraging. Aha! Nice. That actually fixed it. Okay, let's actually test it properly. Does the stuff still work? No. So it no longer works. Because I need to implement debug-ui now. Obviously. I forgot about that. The only thing I'm here for is to implement this commonly, and I've forgotten to do it every time. So what we're going to do is just replace this with using device common renderer Vulkan. You'll see why I'm doing all this effort soon. So if we're using that now, we don't have our own implementation anymore. I'll copy this now, so I can reuse it for both. Right, so what needs to change here? Renderer Vulkan. So firstly, that's an obvious fix. This is just R now. Just a toString ID. What would that be? Just string, right? What was the other one? There's no way it's not that. Imgui. That's just debug-ui. Include. Whoa. Debug-ui. Debug-ui header. Let's go back to where we were. It's not complaining anymore. This needs to be gone completely now. I'm seeing a Vulkan error here. That's not looking fun. I don't like the sound of that. Okay, everything's exploding. Device Vulkan does not name a type. Not sure I believe you. Imgui is not being declared. Something weird's going on. Oh dear. Device HPP 31, which is this. Imgui is not being declared. Even though I have included it. I have some idea as to what this is. This might be a circular include. Because it's nonsense, right? What's the best way of fixing that though? Should that be the case? So device Vulkan includes this now, which means device includes this. So debug-ui includes the generic device header, which includes this file, which now includes this. And that's also trying to include debug-ui. So let's think. I want to get the imgui header without debug-ui. It should be doable, but a bit gross. Always get sidetracked by stuff like this. So if this is really cheeky. This is probably not the best thing I should be doing, but does that fix it? What it does do is lag the hell out of my PC. Oh no, that's the same line. Okay, it seems happy with that. I'm a little surprised. Does debug-ui work now? It does. Did I use... okay, so that's actually correct. Because the render aside actually needs to be done. So I'm seeing errors here. Is in use. Do you do that every time? Is that because it... Does that happen on Triangle Demo as well? I won't fix this now. This is going to be horrible Vulkan stuff. But I want to see if this reproduces on a non-compute thing. It does! Huh! I'm kind of surprised. I know what it is. That would be what it is. Okay, I'll fix that soon. Maybe in the stream, but I don't want to get sidetracked right now. We'll just let this stay here for now. This is going to happen whenever we close the app. That's fine. So this is done. Let's clear this up a little bit. This is hellish. So we just did the Vulkan device. We now have this. You can see it's using some common functionality, doesn't implement it itself, which is great. So our Triangle Demo, everything still works. This is still here, but it's a little bit better now. So, you might ask, why is this better? Haven't we just complicated things for no reason? Why have we added this class? Well, hopefully it'll become more obvious now. So let's go into device, in the OpenGL side. I would like the CVP as well, but not quite yet. So, in here we implemented getRenderer debug-ui. So we keep this as we did before in the Vulkan one, but these guys can die now. Let's comment them out for now. And then we'll just say using device common renderer OGL get renderer. Same thing for debug-ui. And then we need to inherit from this new thing, device common renderer OGL. Probably going to need to include a new header. Where do I want to put it? Probably here. No, I'll put it here. The common front end this time, just device. Okay, that's good. Now let's fix create renderer. So this should be really easy. Just to remind myself, what does the Vulkan one do? So the Vulkan one's a lot simpler. Sorry, a lot more complicated. So we're going to create renderer. So you can see it has all this extra stuff. But this should be really simple actually. Return device common renderer OGL and place renderer. Is that it? I think that's it. And then these go away. These guys die as well. We don't use these anymore. We use the common implementation. And look, there was some duplicate code here. This, we just completely delete it now. So Vulkan should still work. This is still Vulkan. We've just changed the OpenGL side. Vulkan hasn't somehow broken. That's good. Let's do OpenGL. How does this look? Okay, this looks promising. This should all work as before. Also without the bug, yes. Change as many of these as we want. Let's change the actual background colour, and look, it's completely fine. Isn't that great? Nice. Nice and bright white. Okay, this is pretty good. That's made life a little bit easier. I would like to do some common renderer debug UI as well, but there's definitely going to have to be some parts which are specialized, and because I don't really know what I'm doing with it yet, I'm going to keep it that way. So what I suggest we do is keep this. So this is the only new one. That's good. Everything else changes. Let's do some tests. Oh. Ah. Okay. This is because the API changed in the last episode, so I won't do tests for now. We'll test it afterwards, after we fix everything. I'll commit this and then we'll start working on fixes. Then hopefully we'll end the stream once everything is in a working state. So we'll add all this, and we'll say added new device common helper class, which has generic implementation of get renderer place renderer helper function for create renderer and debug-ui. All the debug-ui for the device does right now is invoke debug-ui function on all renderers. Okay. I always forget the name of this stupid branch. Device renderer debug-ui. Productive. Good. So it doesn't look, I guess it doesn't look that productive because not much has actually changed apart from nearly everything's broken. So there's something else I wanted to do, but I don't remember what it was. I think I wanted to start fixing things. Yeah. So OpenGL's fine, nothing crashes when I close. It just says terminated and then we're good. But Vulkan, we've got a nasty new bug. So it opens fine. I close it, we get this. Now I think I know what the problem is. So if we have a look in debug-ui, actually what I'll do is try a non-debug build. If I'm correct, I guess this won't happen in debug build anyway. Firstly, let's see if a release build works. That makes sense. I haven't tested release in a while. I'm not sure if you'll actually see it pop up. I won't bother showing you because it's just going to be a triangle anyway, but you'll have to take my word for it. Seems building okay. It's popped up for me. It works fine. Doesn't seem to be crashing. Ah! So notice, it says initialized, but it did not say terminated, like it would before, which means that it's probably actually crashing somewhere. That's kind of surprising. We're going to debug for now, so there's probably something quite broken in the Vulkan side. I was hoping it wouldn't randomly turn into this, but this was destined to happen at some point. So my first suspicion is a debug-ui. What's my suspicion? So previously, these were unique pointers to renderers, which means that when this render data was destroyed, these unique pointers would go out of scope. Everything would die. But actually, here's a good question. When does this happen? Do we have our triangle demo? Have the debugger out this time? You still can't see this. Hold on, 1 second. I'll fix that for you right now. There we go. So our triangle's back there. Close it. We'll get our crash. So, let's debug this. Firstly, where are we? We're killing a fence. Yep, that makes sense. In a device Vulkan. Why is that? Normally, the renderers would last until the device, normally, because the device dies last, all the renderers will be dead by the time the device's destructor is invoked. Ever since doing this, is that the case? No, that's not the problem. The devices now control all of the renderers when and where. Hold on, this is quite important. Another question, did this start happening? When did this happen? So this is important actually. So this obviously reproduces now. Cool. If I git check out head 1, can I do that? Yeah, so this is the previous commit now. Let's go back there. See if the issue reproduces here. I'm curious if it does. I might have to go even further back. It doesn't. So we know just now, in the thing we just committed, that's when it broke. Okay, that's a little surprising. Let's think. What did we actually fix? What did we actually change? Well, what we did was we made this common device common class which stores all the renderer stuff in it. But before it did that, if you remember, if we look back here for example, debug-ui device. So we now, it used to be here, you see, it used to be the last thing out of all of these. So the render scheduler would die in a certain, is that before or afterwards? Well, the device is first, so it dies last. Okay, so the renderers would all die before this scheduler dies. I think. Yeah. So the renderers all die before the scheduler dies. And the schedulers can die and it's absolutely fine. Now we're not doing that though. Can you please take me back to where I was? No. Ugh. 1 second. Was it renderer? I forgot the name of the branch. Was it device renderer debug-ui? That was it. Let's go back. Debug-ui. Okay, so now we should be back where we were. Please, I don't want to be here anymore. Okay. So now we should be back. Yeah. We have a device common back. So now, the device common is going to be right at the top here, which is not good. This is a really subtle bug. Also, that doesn't need to be there anymore. That's a silly mistake. This is more complicated than I thought. I've changed the order of these things dying. I really don't want to do that. Because the base class stuff is going to be at the top. I can't really change that. And if the renderers die before these die, that should be okay. But if this dies first, then you're trying to kill fences before they're done being used by the renderers. So, what we could do, okay, here's what we could do. Let's go into the CVP file for this. This isn't too bad. So we need a custom constructor now, which is a bit gross, because I'm not following the rules of 5. I never was anyway, I suppose. Device Vulkan. So now what we're going to do is, this is our, based on an instance, copy constructor is deleted, so we do device Vulkan. We implement a destructor here. Firstly, I just want to double check that the issue will reproduce. that I've reset everything correctly. Let's let it build. My music has stopped. I would like some music, please. Here we go. Okay. So, for the first time ever, we want this to crash. Crash, please. Nice. Hooray. Wow, our code's so good. So now, when this device Vulkan ends, what we want to do is find a way to make the thread block until all the renderers are done with their work. That should be pretty easy. We have fences everywhere. Render schedule. Wait framework complete. This is literally what I want to do, isn't it? Scheduler. Wait framework complete. Does that just fix everything instantly? If this ends up being a one-liner, then oh, that would be amazing. Okay. This looks fine. Die. Don't crash. Well, that's not quite what I wanted. Some allocations were not freed before the destruction of this memory block. So there's now a memory leak. How is VMA leaking? How is that possible? Actually, how is that possible? That doesn't make any sense. Give me the debugger. I'm a little confused by that. Okay, die. This is a crappy assert. That's really annoying. Okay, let's think. Let's just think this through. You wait for the framework to be complete. So the destructor is invoked before all of the variables die. So these renderers are all still alive. That's for sure. Am I going to do that? That's not very clever. Maybe I will. This is kind of bad. I think there's a way for me to do it from the device. Backend Vulkan 2 logical device. I want to just stop until everything's done. Maybe what's happening is it's not waiting for the correct time. I'm not sure if that's going to fix it. Wait until idle. That's what I want to do. I don't think there's anything wrong with using this. This is kind of gross and ugly. I just want to see if this fixes it. I'm not convinced, actually. Please? No. I have found a really ugly bug. That's not fun. I guess the first question would be, does the destructor happen before this issue? It should. Let's think. To be the get-ui device, CVP, line 348. Go there, please. This shouldn't happen yet. Now it should happen. Okay. So as soon as it starts killing everything, the allocations were not freed. Never ran into this before. Why would this be causing it? I mean, the fact that the order has changed strongly implies that it's not related to the amount of work that's ongoing. Or at least when I fix that, that helps. But it doesn't have enough time to free the allocations? Which sounds a bit weird. That's kind of weird. Oh, I really didn't want to be in Vulkan land in this stream, but it looks like I have no choice. So that's pretty weird. VMA native. My guess is that that's probably happening in here. VMA destroy allocator? Yeah, probably this. Let's try this. VK2, logical device, CPP, 301. Everything should be fine. Boosh. This should be it. Okay. So there are some allocations which are just not done when this device dies. Why is that? We're waiting until the device is idle before it dies and kills everything. It's because the renderer is outlasting the device, which cannot happen, ever. So what we actually need to do here... Okay, this is the easiest thing to solve in the world. I've been so stupid. I'm being really stupid. Here's what we do. Front end, common, device. So, we need some way of doing an internal clear, basically. These renderers need to die at a specific time. And because the order of destructors changed, Dark Cyber Skills 447, hello! Sorry if that was a really late reply to your message, hope you're doing okay. So we need to be able to clear this. We'll call it internal clear. I want it to be very obvious that no one should really be using this function aside from me. Internal clear. This is going to be the easiest thing in the world. Renderers. Dot clear. Okay, so quit this. The issue should reproduce still. Takes its sweet time. Welcome. If your project gets larger, that is inevitable. Okay, crash. Great. So now we're waiting till the device is idle. I don't think we need to do that anymore. We can do the better thing, which is wait. Oh, what was it? Wait framework complete. Shouldn't really matter. But what we need to do now is this device column. Renderer, Vulkan, internal clear. This is what should fix it. Let's see. All the devices die in the destructor. Sorry, all the renderers die in the destructor. And the bug is fixed. Well, that's so satisfying. That's good. Let's see if OpenGL actually works now. Theoretically, I haven't changed anything. OpenGL doesn't need to do this. Maybe it should anyway. No, I don't think I'm not going to add it to OpenGL just because it caused problems with Vulkan. So, it shouldn't crash here. Okay, everything's working again. That's brilliant. Let's commit this. Fixed a fairly high priority bug. Just don't ever run Vulkan applications and you avoid the bug. Nice. Where Vulkan applications would crash on shutdown. This bug was introduced in the previous revision, but should no longer reproduce as of now. This bug is also not tracked on GitHub issues because it was solved on stream. Sweet. Forgot the branch name again. Unbelievable. Where is the professional within me? Okay. Great. Well, that was productive. That was a challenging one as well, but we got there in the end. What can we do next? How long have we got? So it's been about an hour. Maybe there's time to do a little more, but it's not going to be particularly fun. Actually, let's do something a little bit more fun. So, in the last stream, I did something very dangerous, which is changing the API for the renderer. So yeah, no, sorry, not the renderer, the device. Create renderer used to return just the renderer object directly. Now it doesn't do that, it returns a handle, and the way you handle renderers is now completely different. I updated a demo and a debug-ui, which means that all my tests now go boom. probably fix those. But tests are very boring. You guys don't see anything when the tests run. But the demos, on the other hand, you can see something. You might even see something you recognize if you've watched one of my only videos that's useful in this in this scenario. So let's start with the dynamic triangle. So we've done triangle demo. This is the one you've seen this entire stream. Same with the compute demo. These work fine before it crashes. No, okay. But these are not the only demos. There's a lot of these. So let's go through each of them, try and get them to run again. So let's start with Bloom demo. That's the next one. Get ready to run it as soon as it starts working. Bloom demo. This should not build. Let's have lots of space. Demo gltz Bloom demo. Okay, so line 80 is where things go wrong. This is obvious. Render a handle. Just call it combine h. Easy. So this is annoying. Oh, that's really annoying. That's annoying as hell. Okay. It's a demo, so it can be a little bit gross. Don't judge me for this. We're going to temporarily have a... No, can't be const. Renderer combine is equal to device get renderer combine h. Everyone's happy again. But as soon as this happens, as soon as this renderer is created, this reference is now invalidated, so I cannot use it again. I would add some braces to introduce scoping, so this can't possibly be used afterwards, but I can't because all of these need to be in the correct scope. So this is fine, this is safe now. Let's make a handle for this. However, nothing can use combine anymore, so let's be really careful. In fact, we're going to call it combine old. There you go. Just to be super safe, because I don't want this going wrong. Combine old. Combine old. Oops. Combine old. Okay, that seems good. So now this can't be used, so we're going to have errors everywhere now. It looks like these are the only renderers used, so now let's make everything super easy. So render a handle now. Renderer combine is the same thing as before, except we have to do it again. Could theoretically not make this a problem, but it would have a performance cost that I'm not willing to take, so I'm happy to have disgusting code in here for now. Get renderer. Run now, please. Okay, you can't see it. I will fix that. There we go. We can see a very blurry looking triangle and a very blurry looking square. This is a very basic demo, as you can see. Not impressive at all, really. There's a few things you can do. Firstly, the shapes. So let's take the triangle, for example. We can move it around if we want to, and you can see the kind of blurry edge meshes with the square. And this is using a very bootleg implementation of Bloom. Calling it Bloom's kind of an insult to anyone who does graphics, and if you do, I apologise. I'm fully aware this is not real Bloom. This is a glorified Gaussian blur. So we can play with these a little bit, but ultimately we just want to make sure it works. It does seem to be working fine. Just for a bit of fun, let's screw around with the bloom. These are some default thresholds. As I increase the threshold, the bloom becomes less pronounced. Obviously at the max it just goes completely white. So we have a normal threshold, otherwise it's kind of boring. But the blur length kind of expands the bloom, although it gets a little distorted if I make it too big. So at 0, no bloom. As I increase it, the bloom gets bigger, and bigger to the point where you can very easily see the blurred triangles. It looks terrible. I can fix that with more iterations though, but as those get really high, the effect kind of breaks down once again. It looks awful. Anyway, that's Bloom demo. Let's check it works on Vulkan as well. It's important that we check Vulkan as well. Build for Vulkan. How does this look? Can you see it? You can see it. All the stuff should be fine. Whoops, don't care about that. Give me some crazy bloom. Yeah, lots of bloom. We love it. Absolutely disgusting amounts of bloom. Sweet. So stupid. Okay, cool. That seems to work. Hold on a second. Okay, yeah, it is fine. It's being a bit silly. Yeah, this is completely fine. Cool. So, Bloom demo is good. The blur triangle demo. This is not an interesting looking demo, but it's useful for testing, so it exists. Triangle demo. Let's just build it for now, and it's going to explode. Very fun. Blur triangle demo. 47. So here we go. Same thing every time. Right, 2 renderers. We have to make handles instead. Fortunately, it's not the most complicated thing in the world. This gets a bit ugly, obviously. Because now I have to do the get renderer here. Blur renderer H. Like, that's a bit of a long line. Call this renderer H. This is a handle now. And now we can add the renderer references. We can do that now, so let's do that. Renderer blur renderer equals device get the renderer blur renderer H. You notice code here are exactly the same, but I cannot take the reference and cache it because this ends the lifetime of the reference back then. So we do the same thing for the new renderer. Just call it renderer. I've said the word renderer so many times, kind of don't know how to say it anymore. But that's what happens when you work on graphics, I suppose. So this should be the API fixed. It should build fine. Good. Let's run a demo. I'm almost not going to bother showing you it. Oh, I'll show you it. It's not very impressive though. Blur triangle. There you go. There's the blur triangle. There are no config settings at all. This is it. Yep, not very interesting. Let's move quickly on. But this is useful for testing, that's why I keep it around. This isn't really something you show off to people. So I don't really know why I'm showing it off to you. I wouldn't unless I had to fix these, so I'm trying to make this a little bit enjoyable at the same time. I'm not sure if it's actually fun for you though. Let's have a look at the dynamic triangle demo. This one has a little bit of an epilepsy warning. Warning you now. I won't run it quite yet, but once I fix the API here... Oh, I'm stupid. I thought it didn't need any changes, but it definitely does. Dynamic triangle demo. So this is a little bit like the triangle demo, except it continually puts more and more triangles in it, and they all have textures and the pixel data is randomized all the time, so it is insane. Right. So this should be super quick to fix. Yeah. So what I'm going to do here... If I could spell, that would be great. Renderer H. Where's renderer H? That's right here. I always forget that thing, keybind. Okay. Epilepsy warning. If you have epilepsy, stop watching now. I will tell you when it's over. Here we go. You won't be able to see it. Okay, 3, 2, 1. Yeah, that's ugly. So what's going on here? So it's probably quite hard to explain. So you can see there's a lot of flashing, and once in a while everything gets really chaotic and ugly and disgusting. There's one triangle in the middle. You might be able to make it out now. As it fades out, it's hard to see. As it fades back in again right now, you can kind of see the triangle again. And all these horrible lines and effects around it, those are all triangles. I wonder if we can see how many there are right now. Not for Vulkan. That's a shame. Let's test the OpenGL side and see if we can count the number of triangles it does. That would be really cool. And that will be using work we did yesterday. So all the work I'm doing here is actually very relevant indeed. It feels a bit laggy at this time. debug-ui, this is our guy. And look at that, you can see the triangles going up. That's quite cool. So you can see, like, not many triangles right now, 300, but they stack up all next to each other, and it becomes a disgusting, horrible mess. And what I like to do is I will let this run all night, and about 9-10 hours pass, and this triangle count is approaching 100,000, right? And then if we can see, oh, the performance is fine, it's kind of a good sign that our kind of core mesh rendering functionality works well. I think Vulkan's a little bit faster than OpenGL. I'm definitely feeling it's a little bit jumpy, jittery here. I'm seeing that myself. If you see it on a stream, then it is genuine jitter. In fact, I actually dropped a few frames there, I think, which is quite funny. So, let's stop with that one, because that is disgusting. Epilepsy warning is over now. No more epilepsy, for this demo at least. So, next is terrain demo. Now, you might recognise this if you've watched one of my other videos. It'll be fun to see this feature again because I was quite proud of that video. It's the first one I ever made really and put any effort in. Terrain demo. And here it is right now. Here's the code. She's really not that long, 150 lines. And nearly all of that is, key input, mouse input. Not so much the rendering part. In fact, the rendering part starts here, some shader stuff, and ends about there. The renderer edit is just enabling wireframe mode. I'm not going to count that. So that's pretty cool. Anyway, let's get it running. So what line? 56. Right here. Once again, this is going to be absolutely trivial. Renderer. Whoops. Get renderer. That's the formal word for it. Whoops. Handle. Renderer H. Here we go. I'm going to have to display it for you again, aren't I? Oh, I need to fix my streaming setup. Okay. If you've watched the video, there you go. You might recognise this. Here we go, we're back. I don't know if much has changed since the video. I don't really think so. If you have, let me know if something looks different. For the most part, everything should be the same. So OpenGL, this runs fine. I will play a little in here, but I will play on the Vulkan build. You can see this is the OpenGL build, so let's really quickly swap. Vulkan debug. Build it again. I just want to see if it works. There we go. Cool. And it seems to work absolutely fine. Frame rate looks fine. We could maybe do some profiling. We won't do any profiling today. Maybe in the next stream we'll do some profiling. Just to see where's all the time spent. How many FPS can this run at if I really push it? This is obviously a debug build, so it won't do that much. We can enable wireframe mode, and you can see, you might remember the effect where as the terrain is being scrolled over the geometry, it looks a bit jittery. If I look really closely, you might be able to see it. Okay, it's really difficult to see. I'm not sure if you can notice that, but there's still that jitter effect just slightly. If you look at the water, it becomes really obvious. It's almost as if the water is flowing. We've kind of got this water flowing effect for free. It looks terrible, but there you go. As soon as you stop moving, the water stops flowing, which is a bit weird, but that's fine for now. Let's fly around. I don't think I can arrange the speed, so I'll just do a little bit of a flyover. This was so much fun to make. I would definitely like to make another video similar to this at some point. I'm not sure, should I make a separate thing? Should I make a video about a separate kind of application? Or do you think it's a good idea to extend it? Maybe we can have some foliage, or have the graphics not be as terrible. Actually render something that looks nice, maybe. That could be fun. Maybe some real water as well. But yeah, okay, terrain demo is good. Let's move on to some of the more boring ones before the stream ends. Just so we can all sleep better, I guess. Oh, actually no, that's all of them. Great. Okay, that's surprising, that was quicker than I thought. So here's the demos that needs to change. Let's just commit a change saying fixed use of API breaking changes in all the demos. Forgot the branch name again. Never remember it. There we go. That was very productive and I guess kind of fun to see terrain demo return in a stream. Right, I'll probably call it there. Thanks for tuning in if you're still there. Might stream again tomorrow. This might become a daily thing, it depends. I definitely won't promise I will be streaming every single day. So don't get mad at me if I don't turn up tomorrow. But yeah, I hope you enjoyed. I hope you maybe learnt something, or just had something to listen to, or had something to watch before you go to bed. So yeah, thanks everyone.